Imagine you own a company that specializes in building escape room puzzles. Now, this new puzzle that you're designing contains 3 different colored boxes, and the goal of this puzzle is to connect them with electronic leads in the correct order, with the last box being connected to some kind of computer. If you connect these boxes in the correct order, then the computer will unlock a safe. It will send a signal. It will send a signal to a safe and unlock it. But you might be able to see a slight problem here. Let's say this piece of paper holds our clue. And solving this clue will tell us which order we need to connect these boxes. But hopefully you can see a problem here. Why bother solving the clue when we can test all possible arrangements of these 3 boxes? For example, we might connect it in this order first. And if that doesn't work, we might try and connect green to purple to orange, or orange or yellow first and green last. But with these 3 unique boxes, how many different combinations do we have here? Well, if we arrange all these boxes for all possible combinations, we get an extra 5 possible combinations here, where this is the first combination, and we've got 5 other combinations here. Now, why bother wasting time trying to solve this clue here when we can possibly try all these combinations in, say, a minute or a minute and a half? We would need more colored boxes to increase the number of possible arrangements here. And there's a specific rule that we can use to see how many different combinations there are for n number of unique items. So we've got 3 different items here, and the number of unique combinations can be represented by 3 factorial. And 3 factorial is equal to 3 times 2 times 1. And that equals 6. And this is the number of possible arrangements we can have when we've got 3 unique items. So having 3 boxes is not going to be enough for our puzzle. What if we add 4 boxes? How many arrangements can we have with 4 unique different boxes? Well, this is a 4 factorial problem, and 4 factorial is 4 times 3 times 2 times 1. And this gives us 24 possible combinations. Now, this is a bit better because it will take a lot longer to try out 24 different possible combinations, and it would be much easier just to try and solve the clue. What about 5 different boxes? How many different arrangements can we have with 5 different colored boxes? Well, this will be 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. And we get a value of 120 different arrangements. Now, hopefully you can start to see a pattern here. So let me ask you this. If we had 10 unique different boxes or items, it doesn't have to be boxes, it could be different types of flowers, or different colored pens, or different books on a bookshelf. If we have 10 unique different items, we're going to have 10 factorial. What's that equal? Now, luckily, your calculator will have a special button like this, and this stands for n factorial. So, if I have a value of 10, and I press this button here, it will automatically multiply all these numbers for me. So 10 factorial, or 10 unique different items, gives us 3,628,800 possible different arrangements. So you may be asked this type of question. We have 6 unique numbers here. How many different 6-digit numbers can we construct from this sequence? So because each number is unique, there's no repeating numbers here. We have 6 factorial possible arrangements. And using our calculator, 6 factorial is 720 unique different arrangements. So for example, we could have 7, 5, 1, 2, 8 and 4. That would be one arrangement. What do we do when we have 2 factorials that are divided by one another? For example, 8 factorial divided by 3 factorial. What do we do? Well, we can either write out 8 factorial in its complete form and 3 factorial and cancel like terms, or we could use our calculator, find out what 8 factorial is, store that, and divide it by 3 factorial, which is 6. So 40,320 divided by 6 is equal to 6,720. What if you're confronted with this problem? 7 minus 2 in brackets factorial. What do we do here? Well, we work out the sum within the brackets first. 7 minus 2 is 5. And this equals 5 factorial, which equals, and that gives us a value of 120.